drip through its atmosphere for only days before they sink, so their presence means fresh crumbs always arrive. Within the ring the traffic never stops. Debris orbits at tens of kilometers per second, confined to a plane by countless gentle impacts that shave away vertical motion. Temperature tiers stack like isotherms on a map, innermost dust sublimates at a few thousand Kelvin, leaving a clean gap. A little farther out, silicates glow in the mid-infrared. Beyond that, darker organics persist, loosely bound until radiation erodes them. In that cooler belt, islands of slightly denser rubble plow through the disk like snowplows, accreting fines into soft embryos. It is a paradox only in poetry, a planet born after its sun's old family died. The chemistry of the ring, rock flour, metal splinters, volatile frost from imported comets, yields a recipe different from the first generation. With angular momentum supplied by the torus and cooling aided by radiating heat into the black, clumps can grow, especially where gas, sputtered from hot grains, provides a gentle drag that shepherds dust into vortices. If the seed survives the traffic and resists the dwarf's tides, it can round itself, become a small world with a skin of glassy basalts and a core speckled by diamond-bright inclusions, heir to a ruined lineage. The rare comet in this tableau, green-tinged and soft-haired, is a messenger from the deep archive. Mass loss during the giant phase diluted the central gravity, puffing up every orbit, resonances shifted, outer companions, if any, twisted paths through Kozai, lit of cycles that pumped eccentricity skyward. Icy bodies that once dozed in distant reservoirs fell inward on skimming, elongated tracks, briefly igniting near periastron as sunlight freed cyanogen and carbon radicals. Some will shatter and settle into the ring, some will graze the torus and escape, their tails briefly writing the system's new history in vapor and dust. Even in direction it looks like a pale river poured across the dark, in another like the long spine of a barred metropolis circling a hidden dynamo. To the eye it is a milky sash, to the radio it is a lattice of hydrogen filaments, to the infrared it is a warm braid of dust lanes, to the high-energy gaze it is a snowfall of supernova shards. Call it the island universe of our ancestors, the disk we call home, the galactic boulevard, its many names are just facets of the same slow wheel, the great background against which this intimate drama plays out. The central relic, though modest in size, is a physics conservatory. Electron degeneracy pressure props it up, numbers, not temperatures, decide whether it stands. With mass below the Chandrasekhar brink, it sleeps, cooling as photons and eventually neutrinos carry away the last of the red giant heat. In the deep interior, ions crowd so closely that they arrange into a crystal as the star ages. The latent heat of freezing briefly stalls the cooling, a stellar version of a phase change plateau. Astroseismology hears that structure as tiny, regular flickers in the light, while infrared measurements read the ring's warmth to measure the dust budget, and optical spectra count the metals that rain down like confetti from a banquet of broken worlds. Sometimes the ring itself turns gaseous where collisions vaporize rock, then calcium triplets whisper from a glowing, Keplerian ribbon, letting observers weigh the orbit as surely as a jeweler weighs a gem. Dynamics writes the future in pencil. If a distant survivor, say a Neptune mass remnant or a brown dwarf companion, tilts the system with its distant gravity, the ring can warp, precess, and thicken, feeding the dwarf episodically like a heartbeat. If magnetic fields thread the gas, magnetorotational turbulence can stir the torus and hasten its drift. If a newly forming planetoid grows big enough, it carves a wake, opens a scalloped gap, and steals angular momentum from the ring as surely as a moon shepherds Saturn's edges. The outcome is not guaranteed. Some systems will grind themselves into nothing, some will stabilize into jeweled bands, and a fortunate few will sculpt second-generation worlds, dark, glassy, metal-rich, with skies lit by a tiny white sun that never sets far from the horizon. Everything here is aftermath, but aftermath is not the same as ending. The red giant winds that once stripped the system left trace elements baked into dust. The planetary nebula that briefly made a flower around the star has dispersed into the larger disk of our stellar city. The dwarf cools, atom by atom, crystal plane by crystal plane. Yet the ring continues to sort itself, and the embryo continues to sip the fine powder drifting past, and the rare comet continues to write green punctuation across the scene. In a billion years the dwarf's heart will be more diamond than fluid, and the ring will have thinned or been renewed by fresh infall. The small world may have matured into a dense sphere with a magnetic murmur and a surface etched by micrometeorite rain. If there is a listener there, an instrument, an eye, a brief visitor from another reclaimed system, they will find a quiet but intricate order, a gem at the center, a memory for a sky, a river of stars we can call the Milky Road, the barred avenue, the stellar braid, and beneath it the patient industry of dust learning, once more, how to become a planet. Tides do most of the carving. A fragment that strays inside the dwarf's Roche boundary is seized, stretched, and unspooled into a train of shards that march along the same orbit like pearls. Mutual collisions sand those shards to dust and vapor. The hottest vapor fluoresces, writing double-peaked spectral lines that track the ring's Keplerian speeds with the precision of a seismograph. Gravity settles any heavy atoms that sneak into the dwarf's surface on timescales of days to weeks in a hydrogen skin, longer in a helium one, so persistent metals in the spectrum are not fossils but fresh rainfall. The accretion rate flickers as the ring feeds and pulses, quiet months, then a blaze, each episode a small meteor year for a star that has already outlived its sun-like youth. Radiation provides the slow hand that keeps score. Pointing, Robertson drag steals a whisper of momentum from every grain, making circular orbits decay with time, while the Yarkovsky effect, born of day, night temperature contrasts on spinning pebbles, nudges the larger pieces radially like invisible oars. Farther out, where the torus cools to a few hundred Kelvin, ices survive and organics hide in the shade of rubble. Closer in, silicates soft glow at 1,000 Kelvin until sublimation trims them away, sculpting an inner edge as crisp as a lathe-cut rim. Between these zones, eddies and pressure bumps collect powder into crescents. Vortices act like cosmic edams, trapping chaff and feeding it to any seed solid that can hold its shape against the tides. Now and then the ring betrays a larger body. A shallow, oddly shaped dip in the dwarf's light hints at a disintegrating planetoid trailed by a dusty tail. Successive dips slide in time as the fragments reshape, like a migrating fleet losing ships to attrition. If a survivor grows to dozens or hundreds of kilometers, it can open a feathery gap and herd the flanking dust into brighter arcs. Gas released from high-speed micro-impacts adds just enough drag to tighten the spiral of infall, while weak magnetic fields thread the ionized fraction and stir a low rumble of turbulence that keeps the torus thin but alive. The chemistry tells its own biography, ratios of magnesium to iron, of calcium to silicon, of oxygen in excess of rock stoichiometry, all fingerprints of cores, mantles, and crusts that once belonged to differentiated worlds. The compact star itself remains a workshop in condensed matter. Deep inside, ions lock into a crystalline lattice as the energy budget dwindles, releasing latent heat that briefly pauses the long fade. The outer layers conduct heat so efficiently that the dwarf cools almost isothermally through its tiny radius. Asteroseismic tremors, minute brightness pulsations with clockwork regularity, reveal stratified layers of helium atop carbon and oxygen. In some elders, a frosting of hydrogen sits like hoarfrost over glass. Magnetic cousins boast fields that could strip a credit card from continents away. If our relic is one of them, cyclotron hum might leak from the innermost gas, and accretion could arrive in narrow curtains, painting the poles in soft X-ray glows. Comets remain the archivists. Their green comes from sunlight tearing carbon chains and cyanogen apart, a chemical aurora that flares at perihelion and fades to invisibility on the outbound leg. Each visit is a gravitational tap on the ring, a barely audible metronome that, over millennia, can warp the torus or tilt it a degree, enough for precession to sweep the line of nodes like a slow second hand. If a distant companion, perhaps a cold Neptune, perhaps a failed star, lurks far out, its secular tug can pump eccentricities and feed the inner workshop for eons. The system becomes a feedback loop, outer reservoirs deliver icy couriers perturb the ring feeds the dwarf's polluted spectrum tells us the menu in real time. From our vantage under the Great Star River, the local spiral's backbone frames the scene. The home disk, the barred spine, the luminous causeway, we rename it as our instruments shift bands, finding new architectures in the same sky, molecular lanes in radio, red embroidery in hydrogen alpha, ember-warm dust in mid-infrared, hard sparks of remnants in X-rays. Against that quiet rotation, this tiny workshop burns bright in data rather than light, infrared excesses that betray warm dust, calcium triplets split by orbital speed, ultraviolet nicks where accretion licks at the atmosphere. Telescopes trade sky time to watch these signatures change, because change is the plot here, not a footnote. What grows in the ring is not a twin of earlier worlds. First-generation planets formed from a protoplanetary fog infused with the star's natal mix. This second draft is metal-forward, rock-rich, volatile-poor, salted with odd organics imported by late comets. A mature child of the Taurus might end up with a high-density heart, a thin basaltic crust, and an atmosphere no thicker than a scientist's patience. Perhaps sodium and potassium lines glint in starlight when the world transits, perhaps the atmosphere is gone and electrostatic lofting kicks fine dust into a tenuous exosphere. Micrometeorites would stitch the surface with glass spherules. Without a large parent star's gentle warmth, days would blaze and nights would radiate heat into a freezer-black vault. It would be a stark, durable sphere, a keepsake carved from catastrophe. Time stretches long after the drama quiets. The relic cools through the ages, its core hardening into a true gemstone of degenerate matter. The ring thins, replenished by occasional infall or erased by a final clearing wave. The comet's supply dwindles as reservoirs are spent or frozen beyond perturbation. On scales so large that calendars make no sense, even the compact star will fall dark, a black dwarf with a buried memory of heat. Theory whispers about far future pycnonuclear sparks deep inside such objects, but those fireworks lie beyond any practical horizon. Closer to us is the observable, the present workshop where dust learns to be stone again. To read this place is to read process. Dynamics writes the lines, thermodynamics colors them, spectroscopy supplies the dictionary. We measure a faint dip and infer a shard, we catch a metal line and reconstruct a continent, we count photons in the infrared and weigh a ring we cannot touch. And still there is room for surprise. A sudden, asymmetric flare may betray a fresh disruption, a precession period may not match our models, a new transit may sketch the outline of a body large enough to keep. In the glow of our own galactic boulevard, in the patient turning of the local arm, the aftermath continues to invent. Ash becomes seed, seed becomes stone, stone inherits a sky where a tiny white sun cuts a permanent noon, and the long memory of a system writes itself into a small, enduring world. If we could stand on that newborn worldlet and look sunward, the central ember would be small but fierce, its light slightly reddened not by dust but by gravity itself. Photons climb out of a surface gravity 100,000 times Earth's, their wavelengths stretch, a quiet gravitational redshift that a spectrograph can weigh like a scale. The dwarf's pull also dictates the landscape, horizons are short, escape speeds enormous, and any cliff face remembers tides. Every orbit of the seed is a negotiation between tensile strength and shear. Beneath the crust, grains grind and compact, releasing heat in tiny earthquakes that help sinter rubble into rock. Where orbits cross, slow splashes of pebbles fall like gray rain, fusing a regolith whose glassy beads keep the story of each impact in frozen ripples. The ring's mineralogy is legible if you know the alphabet. Short word of 10 microns, silicate bands sketch olivines and pyroxenes. Farther out, carbonaceous features reveal soot-like mantles on grains, faint shoulders imply metal oxides shaved from old cores. When fragments graze one another at kilometers per second, friction flashes to vapor, and that vapor's emission lines carve a barcode of temperatures and densities. Mid-infrared spectra from a cold observatory can untangle the blend, telling us whether the dust started life in a mantle, a crust, a core, whether water once threaded its parent body's veins, whether carbon-rich rocks, rare in the first generation, are now common in this metal-forward nursery. Geometry matters as much as chemistry. The torus is not a perfect hoop, shadows from inner clumps sweep across the outer belt, making temperature maps that look like the spokes of a slow wheel. Where shadow cools the dust, gas condenses and pressure dips, and grains drift inward to pile along the rim of the shade. That feedback breeds arcs, arcs foster vortices, vortices feed embryos. If a lump grows hefty, it shears a shallow groove and piles dust at its edges into bright crescents that rotate with it, shepherding like a minor moon at the edge of a planetary ring. The scene is miniature, measured in solar radii rather than astronomical units, but the choreography rhymes with giant versions around young suns. The compact star adds a few tricks of its own. Magnetic fields, even modest ones, can split spectral lines into clenched triplets, letting us read magnetism from afar and guess where accreted gas might funnel along arcing field lines. If the field is strong, matter doesn't rain down evenly, it arrives in curtains that light up the poles, and rotation modulates that glow like a lighthouse. At the surface, metals that just fell in begin to sink. In hydrogen atmospheres they vanish in days, in helium they last longer, but the clock always runs. That is why a metal-rich spectrum is a live feed, not an archive. To catch change, wide-field monitors watch for transient dimmings, trains of dusty fragments crossing the ember, light curves with ragged edges that drift from orbit to orbit as the parade spreads and fades. The outer architecture, fuzzy and austere, keeps supplying the inner workshop. A tilted far-flung companion can pump eccentricities with slow secular tugs. The resulting gravitational tides heat some intruders, wake outgassing, and help grind them into the grit that keeps the ring alive. In colder reaches, comets sleep with catalogued volatiles locked in amorphous ice, a nudge, a resonance, a kozai, lit of swing, and they fall sunward, flash at periastron, and either escape or join the ash. Their chemistry is a spice rack, carbon chains, nitriles, sulfides, rare grains with pre-solar isotopes, all get stirred into the ring's recipe, making the second generation distinct from the first. On timescales that mock our calendars, the ring's ledger balances. Inflow from disruptions and comets competes with outflow into the dwarf and with consolidation into seeds. If accretion wins, the torus thins and the dwarf spectrum goes clean. If supply persists, metals stay visible and infrared excess glows on. If seeds accrete faster than they are eroded, the disk develops a family of minor worlds sharing resonant orbits, some in horseshoe dances, some locked in Trojan arcs, some doomed to spiral inward as drag gnaws at their momentum. A few will survive long enough to differentiate, light elements rising, heavy ones sinking, leaving a basaltic skin that reads like an inscription under high sun. Across the sky the great night arch frames the theater. The Star River, the home spiral, the barred backbone, the milk pail causeway, rename it as you please, threads above like a compass that never sets. Its own dust lanes teach humility. We read this single ember-wreathed ring because our instruments learn from dust everywhere else. Radio maps taught us to see molecular clouds, infrared surveys trained us to weigh warm grains, time domain watchers schooled us in patience. Against that curriculum, this small classroom shines. A spectrum with metals is a confession, a double-peaked emission line is an orbit traced in ink, a lopsided light curve is a rock coughing itself to vapor. There is philosophy hidden in the mechanics. Catastrophe, mediated by drag and gravity, becomes order, ruins become feedstock, feedstock becomes structure, structure remembers its origin in ratios of nickel to iron, of magnesium to silicon, of oxygen excess over rock. Even after the compact star cools and its heart becomes a true gemstone, carbon ions locked into a crystal that could outlast empires, the workshop can keep running if the outer stores still hold anything to send. If not, emptiness is a phase 2, and the seed worlds that remain will circle in a hush so deep that only micrometeor rain and tidal murmur break it. And yet quiet does not mean inert. Electrostatic forces loft micron dust at the worldlet's terminator, making a tenuous veil that rises and sinks with the tiny day. Charged grains dance in patchy fields, painting ghost auroras against a black noon. Solar storms are gone, what remains are the dwarf's compact flares, brief and hard, carving the topmost grains and leaving chemical patiny a laboratory could read grain by grain. On some nights, if nights have meaning under a small, bright sun, the ring will conspire to cast a knife-edged shadow across the worldlet's plains, and the shadow's march will be time itself, written in cold. From far away, our instruments will keep translating light into stories. A future telescope will catch a new dip, a fresh line, a warmer than yesterday excess, and we will revise the diagram, move a clump here, add a seed there, adjust the gas fraction, lengthen the precession. What began as ash is now a ledger we can read. What begins as a diamond is a clock. Above, the stellar boulevard of our home disk turns without hurry, and in its faint glow a small system keeps doing the patient work of becoming. A future cartographer of rubble would sketch the orbits here like tight violin strings, each tuned by gravity and tensioned by drag. Close to the ember the lines crowd into minutes-long periods, farther out the staves widen to hours, a score written in Kepler's hand. Within those bars, the collisional cascade hums, big pieces fracture, medium pieces chip, small pieces vaporize, and the vapor cools into gas that briefly thickens the ring and then rains inward. In places where pressure peaks form, born from gentle shocks, shadowed temperature dips, or magnetically nudged clumps, dust dams build up and spill, and every spill is an experiment in planetesimal arithmetic. Add a whisper of gas, subtract a little turbulence, multiply by 1,000 orbits, and a seed either survives or dissolves back into the general drift. What the light curves call dips, the ring calls weather. A fragment passes in front of the dwarf and the star's glow fades in a shape that tells you about the fragment's tail, its porosity, its spin. Ragged egress says clumping, a slow ingress says a dusty coma, a drifting period says the piece is shedding mass, its orbit shrinking as sunlight and tides work together. Stack months of these dips and a map emerges, a convoy of crumbs from a mother boulder, a warp precessing like a hula hoop, a shepherd body none of our instruments can see directly but whose wake is unmistakable. It is transit photometry in miniature, and it works because the workshop is compact and the clock ticks fast. Chemistry turns the starlight into a ledger. Calcium H and K lines, magnesium at 4481A, iron forests in the blue, each says rock, not primordial gas. Excess oxygen beyond what silicates can hold hints at past water, perhaps once locked in hydrated minerals that were baked out during disruption. Nickel and chromium whisper of cores, aluminum and calcium sing of crusts, manganese, vanadium, and zinc, if ever they can be teased out, would refine the story from broad eras to specific provinces of the shattered parent. None of these atoms linger, they drop below the photosphere on timescales short enough that a metal-rich spectrum is a present-tense confession. Watch it week to week and you can see the menu change. Magnetic mood swings add their own signatures. If the compact star's field is measured in tens to hundreds of megagauss, the accretion flow may not form a graceful boundary layer at all, it snaps to field lines and arrives in curtains that rotate with the star. Cyclotron harmonics bruise the spectrum at infrared or optical bands, shallow but rhythmically spaced, a fingerprint of both field strength and viewing angle. Even a milder field matters. Charged nanograins feel Lorentz forces and dance out of the midplane, only to be pulled back by collisions, a continual puffing that keeps the torus thin yet not razor flat. The result is not a static ring but a breathing one, thickness rising and falling with the magnetic weather. The newborn worldlet is a study in compromises. Too small, an electrostatic lofting steals its fines faster than gravity can reclaim them, too big, and tides start to gnaw at its shape each pericenter passage. Its surface bakes on the day side and radiates hard on the night side, a cycle that drives thermal cracking, rock peels and curls, exposing fresher mineral faces to micro-impacts. If the object differentiates, iron threads sink inward, dragging siderophiles with them and leaving a silicate skin pocked by glass splashes. With luck it builds a weak remnant magnetism from cooling metal or impact-generated fields, with more luck, a trace exosphere of sodium and potassium lines the limb during transits, a tenuous script we might one day read. Beyond the ring, the architecture of the old system persists like bones. A far companion, planetary or substellar, can torque the inner ensemble, slowly trading inclination for eccentricity in cycles that span centuries to millennia. Each time eccentricity crests, periastron plunges, each plunge risks disruption and replenishment. In the cold lofts of the outer reservoir, comets nap under black insulation, a resonance drift, a passing star, or the slow pull of the galactic tide in our home disk, call it the star road, the barred thoroughfare, the island city, nudges a handful inward. Some objects skim the ring and keep going, others split and surrender their ash, a few strike seeds and either feed them or shatter them back into the Commonwealth. Observation is choreography between instruments and patience. Wide-field sentinels catch the dips and flarelets, high-dispersion spectrographs weigh the metal rain, mid-infrared eyes tally the dust's warmth, ultraviolet monitors test for accretion nicks at the photosphere. Astroseismology, where possible, reads the dwarf's interior like sonar, numbering the layers of helium over carbon and oxygen, measuring the slow crystallization that releases latent heat and stalls the long fade. Stitch these data into a timeline and the system turns from a postcard into a diary, a flare that matches a calcium spike, a new dip that matches a brightening of the gas ribbon, a precession beat that agrees with a hidden companion's tug. Even the limits are eloquent. A clean, metal-free spectrum after a long polluted era says the conveyor paused, no fresh fragments crossing the Roche boundary, no new comets delivered. A shrinking infrared excess says the ring is thinning faster than it's being fed. Conversely, a sudden metal bloom with no brightening in the dust can signal a mostly gaseous disruption, a carbon-rich intruder, perhaps, or a small, fast rock pulverized to vapor before it could join the grains. The workshop accepts many inputs and turns them into a handful of outputs we can measure. Inference is the art of matching cause to signature without overpromising. On a horizon of millions to billions of years, the plot arcs toward austerity. The compact star's heart freezes toward a true gemstone, carbon and oxygen ions locked into a crystalline grid whose latent heat has long since leaked away. The ring, unless an outer store keeps sending freight, dwindles into stray arcs and finally into a hush. Seeds that survive may settle into resonances and keep each other company around a sun no bigger than a planet, with daylight that is bright but narrow and a sky quartered by the ring's shadow when geometry aligns. Should any visitor arrive, robotic, biological, or merely a passing shard, they would find a museum of process, veneers of glassy splash, regoliths sorted by electrostatics, subtle magnetic scars, and the fossil rhythm of tides written in faulted basalt. And still, the large backdrop does not fade. The local spiral, our luminous thoroughfare, slides above with unhurried grace, in radio, threads of cold hydrogen, in infrared, braids of warm dust, in optical, the pale milk of billions of suns, in X-rays, the afterglow of old detonations. Against that cathedral of repetition, this pocket drama is intimate and precise. Ash becomes ingredient, ingredient becomes seed, seed becomes stone, and stone becomes a chronicle under a small fixed sun. The diamond at the center keeps time, the ring edits its own draft with every collision, the home galaxy, call it the Star River, the barred metropolis, the celestial boulevard, supplies tides and distant nudges that, over eras, keep the workshop honest. Creation here is not a single act but a habit, a long, careful habit of matter practicing how to hold itself together. Instruments that watch in polarized light would see the ring not merely as warmth but as a texture, the way scattered photons line up their electric fields when they bounce off grains of a particular size. The phase curve, how polarization rises and falls with viewing angle, would sketch the grain size distribution more honestly than brightness alone. Add thermal phase curves, the tiny swell and ebb of infrared glow as clumps rotate in and out of view, and the torus becomes a slow zoetrope, peaks marking hotter, denser knots, troughs revealing fresher gaps. On rare alignments, mutual events occur, an embryo briefly occults a bright segment of gas, the gas in turn casts a razor shadow across the worldlet's limb, and those crossings let us solve for absolute scales, not just relative ones. Even the dust's color under starlight is a diagnostic, bluer scattering hints at submicron silicates, a flat hue implies larger pebbles, a red tilt says organics have painted the grains with carbon skins. Laboratories on Earth know some of this story by touch. In vacuum chambers, rock simulants blasted into vapor condense to glassy spherules with textures that betray cooling rates, flash-heated olivines recondense into foams or beads depending on pressure and seed nuclei. Photophoresis pushes hot, cold grains the way a tiny engine pushes a sail. Those microphysics recipes map cleanly onto the ring. When collisions in the inner belt spike, vapor quenches into chondrolike beads that radiate differently than fractured shards, changing the disk's emissivity on timescales as short as a few orbits. Electrostatic charging during impacts makes filigreed aggregates that look fragile but survive in microgravity until a single harder hit compacts them into sturdier pebbles. Each route leaves a spectral accent. Together they write a materials history for a world that is trying to reassemble itself one bead at a time. The compact star's gravity edits every attempt at growth. The classical Roche boundary for rock sits not far above the dwarf's surface in absolute distance but far in orbital energy. Inside it, rubble piles cannot hold shape unless their internal strength outmuscles tides. That is why so many fragments arrive as trains rather than monoliths, and why successful seeds tend to orbit just beyond the worst shear, where a compromise between cohesion and drag becomes possible. Orbital periods there span tens of minutes to a few hours, fast enough that precession and nodal regress creep across human calendars rather than geological ones. Measure the double peaks of a calcium emission line and you can weigh the ring's radius. Watch those peaks breathe over months and you can see a warp turning like a hand on a quiet clock. Occasionally the workshop reveals an origin story in miniature. A metal abundance pattern weighted toward nickel and iron, with depleted volatiles and modest calcium, tells of a core-rich parent, perhaps a mantled mini-world already differentiated before disruption. Another week, an oxygen excess betrays hydrated silicates, past water, not present, but enough to say that the original body once lived colder or deeper. Very rarely, carbon-rich signatures hint at exotica, bodies assembled in unusual nebular neighborhoods or cooked under strange red giant chemistries. None of these linger, they flush through the dwarf's skin quickly, so time series becomes the atlas, a menu shifting from crust to mantle to core as the disruption peels apparent layer by layer, or a mixed salad of many small intruders arriving from a resonant conveyor in the outskirts. Magnetism gives the inner system a weather forecast. When the field strengthens or our view angle changes, accretion curtains brighten and dim with rotation, painting the light curve with a heartbeat. Cyclotron harmonics bruise the optical or infrared in evenly spaced steps. A faint X-ray tickle betrays hotspots at the poles where matter lands and spreads. Charged dust near the midplane feels a Lorentz nudge that lifts it slightly, thickening the ring by a hair when ionization rises during flares and letting it thin again during quiet spells. Even the worldlet's exosphere listens. Sodium and potassium lines, if present, wax after micrometeor swarms and wane as gravity reclaims the sputtered atoms, a breath you can time if your spectrograph is patient and your nights are clear. In the broader architecture, the far companion, if there is one, plays conductor. Secular tugs trade inclination for eccentricity on cycles long enough to lull, then suddenly a crest drives a stored boulder train through periastron and the inner lab lights up, dust jumps, gas ribbons brighten. The dwarf spectrum blooms with fresh metals. Between those harvests, the Taurus coasts, smoothing its own turbulence and feeding the seed worlds at a careful pace. Out in the cold dark above the Star Road, the barred avenue, the island city of suns, the galaxy's tide adds an almost philosophical push, small, patient, cumulative, the kind of force that only matters when you keep the books for 1,000,000 years. If the embryo survives, it learns to manage heat. With a dayside always close to the dwarf, thermal gradients try to crack it. Internal porosity damps those stresses by flexing, microseisms from impacts compact pore spaces into stronger stone. Metal threads settle inward, and if the body is lucky enough to spend time in a weakly varying field while still warm, domains align and a remnant magnetization freezes in, a seed memory strong enough to deflect some charged dust and carve faint auroral arcs during magnetic squalls. Its surface becomes a palimpsest, glass marbles from splash events, welded breccias where pebbles came down hot, frostless plains where electrostatic lofting keeps finds perpetually airborne, rising and settling like gray weather. The endgame depends on supply. If the outer stores and the conductor's rhythms keep sending freight, the ring lives on as a disciplined workshop, raising a small family of second-generation bodies that share resonances and occasional close shaves. If delivery's slow, the torus fades, the dwarf spectrum cleans, and only the seeds remain, coursing around a gem-hearted sun that, epoch by epoch, crystallizes deeper. Long after our instruments fall silent, the compact star will be mostly lattice, a diamond by any practical measure, radiating the last stored heat into a universe that has grown more austere. The star river above, our spiral thoroughfare, will have drifted and rethreaded its arms, but the ledger written here will still be clear in the stones, ratios of metals, fabrics of glass, the fossil timing of tides. In that sense, ash and diamond are not opposites but neighboring chapters, and the quiet craft of their turning is the most durable story the system knows. From a distance the system is solved like a puzzle of light. Forward scattering halos around the dwarf betray the finest flower, while deeper, flatter dimmings reveal pebble clouds. High-cadence photometry turns those ripples into maps, a bright clump rotates into view, the continuum warms by a whisper, calcium and oxygen lines widen, then the clump slips behind the star and the spectrum relaxes. Doppler tomography sketches the ring as two mirrored streaks whose tips mark the inner edge. When a warp drifts through, one tip swells and the other thins, a seesaw that clocks precession without touching a single grain. Polarization adds another axis. The electric field vectors swing with phase, tightening for compact pebbles, loosening for fluffy aggregates, so grain growth becomes something we can watch rather than merely infer. Grains themselves are small laboratories. Their shapes set how they absorb and re-emit heat, their spins, kicked by photon recoil and micro-impacts, control day-night gradients that drive the Yarkovsky and YORP drifts even in this tight, hot arena. Photoelectric charging turns every flare into weather, potentials climb, micron dust lofts, small clumps stick or repel depending on sign, and a passing wave of ionization can turn a sleepy arc into a busy workshop. Fractal bundles compact into tougher pebbles after a few hundred gentle taps. Composition matters too, metal splinters conduct and shed charge quickly, carbon-skinned grains hold onto it, silicates sit between, and that ordering right's faint color tilts into the scattered light. Architecture upstream keeps the conveyor full. A surviving outer planet, even a modest ice giant far from the ember, can trade inclination for eccentricity in long secular cycles, dropping a handful of bodies each crest toward star-skimming periastra. Mean motion resonances act like rungs, stepping rubble inward until tides finish the job and unspool a new train of shards. The ring itself obeys a local Laplace plane set by the dwarf's gravity and any distant companion. A small misalignment is enough to make the torus nod and breathe, and that slow nod turns into a metronome in the emission lines. At the surface of the compact star, the evidence is written in chemistry and time. Hydrogen-skinned dwarfs swallow heavy atoms in days to weeks, helium-skinned cousins keep them a little longer, but not by much. To see iron, magnesium, calcium, oxygen, nickel, sometimes even aluminum and titanium, is to know that rock is raining now. The relative weights read like a cross-section, core lean, mantle-rich mixtures 1 month, crust-flavored ratios another, very rarely a carbon-heavy signature that whispers of odd birthplaces or red giant alchemy. It is a living menu, not a fossil, and watching it change redraws the debris field without a single image. Spin and magnetism lace through the scene. Zeeman split lines measure how tightly the field clenches the gas, cyclotron hum at optical or infrared bands tells where accretion curtains land, rotational modulations reveal spots and funnels that drift as the field rethreads itself over months to years. Even a mild field matters for dust. Lorentz forces puff the midplane by a hair when ionization spikes, then collisions settle it again, so the ring never fully freezes into a razor. Precession of a small warp against the spin gives away the obliquity, and with it the memory of angular momentum the star carried through its giant phase and into its compact life. Worldlets growing just beyond the worst tides negotiate heat, strength, and gravity every hour. Daysides bake, nightsides radiate hard, thermal fatigue peels rock into curls, microquake center pore spaces, impact splashes glaze the ground with thin glass that breaks into beads under the next rain of pebbles. Space weathering breeds nanophase iron in surface skins, muting reflectance and shifting colors. A trace exosphere of sodium and potassium may rise after a meteor shower and fade within orbits, a breath thin enough to measure only during transits. If metal threads settle inward while the body is still warm, a remnant magnetization can freeze in, weak, but enough to curl charged dust above the limb into a ghost of aurora when magnetic weather flares. The wider backdrop keeps time at another scale. Our spiral home, call it the Milk Band, the barred capital, the stellar city, the spiral causeway, lifts over the scene like a slow tide. Its gravity fields, gentle but persistent, tweak the far reservoir, once in a grate while a passing star or molecular cloud adds a nudge. Those pushes are small compared to the ring's close-in shears, yet over tens of millions of years they decide whether freight keeps arriving or the workshop runs out of stock. Interstellar gas offers almost nothing by comparison. Bondi oil drips are a rumor next to a single disrupted rock. Instrumentation turns patience into narrative. Mid-infrared spectra weigh warm dust and separate glass beads from fractured shards. Ultraviolet slivers catch the lick of fresh accretion at the photosphere. High-resolution optics resolve the gas ribbon's double peaks and watch them breathe. Stitch all of it into a time series and you get not a static diagram but a logbook, a calcium bloom paired to a dip train 3 days later, a brightening of the inner edge as a shadowing clump rotates away, a gentle lengthening of the precession beat that hints at a hidden companion's tug. Models become hypotheses you can falsify on a human schedule. Supply sets the ending. If the outer machine keeps sending couriers, the torus remains a disciplined factory, and a family of second-generation worlds may settle into resonances, a horseshoe duet here, a Trojan arc there, around a sun the size of a planet. If deliveries falter, the infrared excess fades, the metals wash clean from the spectrum, and the ring relaxes into stray wisps that drift away or fall in. The compact star continues its quiet crystallization, layer by layer, until most of its interior is a lattice that deserves the name its metaphors have been chasing. The diamond heart keeps perfect time, the ash remembers the blows that made it. Across it all the galaxy river, the barred boulevard, the island city of suns holds the frame. In radio it's a mesh of cold hydrogen, in infrared, a braid of warm dust, in optical, a soft spill of countless stars, in high energy, the afterglow of old detonations. Against that cathedral's slow pulse, this workshop is intimate and exact. Matter breaks, cools, charges, sticks, melts, reorders, orbits trade energy and forget their inclinations, signatures appear and fade like notes on a staff. Creation here is iterative, not explosive, a practice, refined by friction and light, by tides and time, until stone and sky agree on a shape and keep it. Close to the ember, even mechanics acquires flavor. General relativistic precession, small but relentless at these radii, turns every slightly eccentric ringlet into a slow rotating ellipse. The gas listens and its calcium triplet shows a breathing asymmetry as periastra parade. Radiation pressure is weak here, the dwarf is dim compared to a living sun, so grains are not blown out but coached inward by pointing, Robertson drag, a tax on motion paid in photon momentum. The sublimation front is a movable frontier, silicates bow out near 1000 to 1500 Kelvin, refractory alumina and spinel persist closer in, within the innermost gap only gas survives, etched with lines that double peak at orbital speeds that could circumnavigate Earth in minutes. Temperature is a topography of its own, and maps of it, stitched from mid-infrared spectra, show ridges where shadows cool and draw pressure lows, and valleys where warm arcs spill dust downhill. Cooling inside the compact star carries its own signatures. As the relic ages, carbon and oxygen ions settle into a crystal, latent heat from that phase change briefly stalls the long fade, a plateau written into the luminosity curve like a held note. Trace neon nuclei, born long ago in helium burning, sediment slowly and release gravitational energy, another quiet delay that seismology can hear in the pattern of pulsation modes. Each tremor is a sonar ping that counts layers, a skin of hydrogen on some, helium frost on others, then the thick carbon-oxygen heart, together they tell us how the ember reached this stillness and how quickly it will dim toward blackness that the universe itself has not yet allowed any star to reach. Grain growth in the torus is a contest of textures. Fresh fracture surfaces radiate heat efficiently and cool quickly, glassy beads from vapor quench hold warmth longer and drift differently, metal splinters conduct charge and shed it fast, while carbon-skinned grains clutch electrons and stick in ways silicates do not. Under a flare, photoelectric charging surges, micron dust lofts, and like charges repel, briefly defluffing aggregates before collisions knit them again. YORP torques, tiny, cumulative kicks from anisotropic re-radiation, change spins of pebbles until they crack or settle into slow tumbling. The broken pieces present new facets and new sticking laws. What looks from afar like a smooth ribbon is, in the grain's frame, a city of weather, economy, and slow civic engineering. A newborn worldlet accumulating at the disk's pressure crest feels many clocks at once. Its hour-to-hour weather is pebble rain and electrostatic wind. Its day-to-day life is thermal fatigue and microquakes that compact porosity and raise internal strength. Its years are measured in periapsis tides that flex its interior and sort its minerals by density, iron threads slinking inward, silicate foams annealing into sturdier rock. If the body warms enough in a mild ambient field, domains align and a remnant magnetization freezes in. Later, when magnetic squalls gust through the inner system, faint curtains of charged dust curl above the limb like a ghostly aurora. Once or twice per precession cycle, the ring's shadow scythes across its planes, and temperature plunges right brittle fractures that a geologist could read as rings within rings. Supply chains from the outskirts are slow epics in their own right. A distant ice giant, even one exiled by mass loss during the giant phase, can trade inclination for eccentricity in secular cycles that take centuries to crest. Each crest pushes a handful of rocks onto star-skimming tracks. Resonant ladders shepherd them inward, 3:2, 2:1, 5:2, until tides do the final subtraction and unspool trains of shards inside the Roche boundary. The galaxy's broad tide, the slow pull of our spiral causeway, the milk band, the barred capital, the stellar city, adds a background beat that only matters if you keep books in millions of years, a slight bias that, over eras, refills or starves the inner workshop. Observation translates all of this into legible scripts. Double-peaked emission marks the gas ribbon and weighs its radius, Zeeman splitting measures magnetic grip, cyclotron harmonics bruise the optical or infrared at evenly spaced steps and clock accretion curtains as they rotate. Polarization phase curves harden and soften as grains compact, thermal phase curves rise and fall as clumps rotate through our view. When dips repeat but drift, fragments are losing mass. When metals spike without an infrared flare, a body vaporized before it could join the grains. Time series is everything, a calcium bloom paired to a dip train a few days later, a precession beat lengthening in a way that betrays a hidden companion's tug, a warming of the inner edge as a shadowing clump rotates away. Even failure deposits evidence. If a seed grows too fast and wanders inward, tides pull it into a caravan of pieces whose sizes grade from boulder to dust, their light curved silhouettes look like teeth, and their spacing records where the parent began to unzip. If, instead, drag starves it, the embryo becomes a fossil, rounded, glass-skinned, muted by nanophase iron, circling in a cleared lane like a relic bead on a nearly empty string. Either way, the dwarf's atmosphere remembers the last meal for only days, in a hydrogen skin, or weeks, in a helium skin, so a clean spectrum is a pause, not absolution. In this lab, now, is the only tense that counts. On far horizons the plot remains austere and precise. The compact star crystallizes deeper, its diamond heart thickening plane by plane. If freight persists, the torus stays a disciplined factory, raising a small family of second-generation worlds that share resonances, a horseshoe duet, a Trojan arc, a shepherd trimming a bright crescent. If deliveries fail, the infrared excess fades and the ring condenses into ragged wisps, then memory alone. Yet even then the ledger survives in stone, glass spherules from splash events, breccias welded by hot rain, faint magnetic scars, the fossil rhythm of tides kept in faulted basalt. And above, the backdrop keeps its patient pulse. Call it the Milky Road, the barred boulevard, the spiral thoroughfare, the island city of suns. In radio it is cold filaments, in infrared, warm braids, in optical, a pale spill, in high energy, the cinders of old explosions. Against that cathedral's slow turn, this workshop is intimate and exact, ash organized by light and friction, diamond keeping time at the center, small worlds practicing the art of staying whole. Matter here is not saved by miracle but by habit, countless, incremental negotiations with gravity, heat, and charge, until structure persists long enough to be called a planet and a sky persists long enough to be called home. Even the geometry of heat becomes a sculptor. Periastron arcs glow a little brighter where grains linger through their warmest minutes, so the ring carries a subtle azimuthal stripe of temperature that slides with precession. That stripe is not decoration, it is a pressure gradient, and pressure gradients herd dust. Where the gradient kinks, a Rossby wave can rise and wrap itself into a vortex, a gentle whirlpool that traps pebbles the way an eddy gathers leaves. Inside the whirl, collisional speeds drop just enough for sticking to win more often than shattering. 100,000 quiet victories later, the seed at the vortex core is measurably heavier. The gas ribbon keeps time for us in double peaks. When collisions flash rock into vapor, the ribbon brightens and its two horns move farther apart or closer together with the inner edges shifting radius. Small asymmetries, one horn higher than the other, betray a mild eccentricity or a warp, and when that asymmetry nods with a fixed period, we have a precession clock we can set our calendars by. Occasionally the ribbon hiccups, a calcium flare with no infrared bump, implying impact speeds so high that dust went straight to gas and slipped inward before it could cool into grains. Those fast episodes feed the dwarf like a thin intravenous line. There is an acoustics to rubble. The velocity dispersion, how fast grains jitter about the mean, sets the ring's thickness. Hotter in motion means thicker in section, cooler means a blade. Gas adds a hidden cushion, even a trace, ionized by a flare, damps vertical energy and draws the torus flatter. The balance is a moving target. A magnetic squall raises ionization, Lorentz forces lift nanograins, collisions settle them again, the cycle repeats with the star's weather. From afar you see only a slow breathing in the polarization curve and a faint nervousness in the line widths, but those are the fingerprints of the ring's internal chatter. White dwarfs wear their histories as thin skins. Hydrogen mantles are the most common, light, transparent, unforgiving, heavy atoms fall through in days. Helium mantles are rarer and kinder to detectives, metals linger longer, and weak helium lines make the background quieter. Either way, the persistence of iron, magnesium, calcium, and oxygen tells us the rain is current, not antique. Sometimes the ratios imply a peeled parent, crust-rich 1 week, mantle-flavored the next, coralline later still, as if a single differentiated body was being unwound layer by tides and time. Seed worlds learn to bargain with stress. Thermal tides try to pry them apart at periapsis, porosity and sintering push back. Impacts glass the ground into thin, dark veneers that change the surface's thermal inertia and shift how dawn and dusk release heat. A trace exosphere may rise after micrometeor showers, sodium and potassium whispering at the limb during a transit, and collapse again as gravity reclaims the atoms. If the seed cools in a mild, steady field, magnetic domains freeze into a remnant pattern. Later, when magnetic weather gusts, charged dust follows curling field lines above the horizon, sketching a faint, almost private aurora in a sky that never fully darkens. Beyond, the conveyor of supply keeps its slow promises. Secular cycles trade inclination for eccentricity in the far reaches, nudging a few stones per crest toward stargazing tracks. Resonances step them inward like stairs, tides do the last arithmetic and pull them into trains. The galaxy's large tide, the milk band's patience, the barred spine's hush, the stellar city's broad hand, adds only a whisper, but over 1 million years whispers add up. Some epochs the workshop is busy and bright, others it runs on leftovers and habit. Either way, the ledger of metals in the dwarf spectrum tells us which chapter we are reading. Observation has learned to turn faintness into detail. High-cadence light curves catch dip trains from disintegrating fragments and watch their periods drift as mass evaporates. Mid-infrared spectra weigh dust and separate fractured shards from quenched beads by the way they radiate. Optical lines split into clean Zeeman triplets when the field clenches the gas, letting us feel magnetism without ever touching a grain. Over months, seams appear in the data where phenomena line up: a calcium bloom 3 days after a dip train, a horn asymmetry that nods with the same period as a polar hotspot, and the model graduates from sketch to mechanism. Failure is part of the curriculum. A worldlet that grows too quickly and wanders inward is unzipped into a necklace of pieces whose sizes and spacings archive the moment when strength lost to tide. Another that starves becomes a museum stone, rounded by gentle impacts, varnished by nanophase iron, looping forever through a cleared lane with nothing left to eat. The ring remembers both outcomes. Its brightness declines as supply ebbs, its polarization curve flattens as grains compact and then are not replaced. The dwarf spectrum washes toward purity as the last metals sink below the photosphere. Yet ending is only a local statement. The compact star keeps crystallizing, plane by plane, its heart becoming more diamond than fluid. Tiny releases of latent heat and sedimentation energy punctuate the fade like rests in a long score. The workshop may sleep between deliveries, but the outer shelves do not forget, and a distant resonance or a soft stellar encounter can start the conveyor again with a single nudge. When that happens, the signs recur in the same order: dip trains, horn shifts, infrared warmth, metal rain. The plot is reliable because physics is. Overhead, the great backdrop remains a compass. Name it the Star River, the barred avenue, the island city, the spiral highway. The view differs with wavelength, but the cadence is the same: cold hydrogen in radio lace, warm dust in infrared braids, pale starlight in optical spill, old detonations in high-energy cinders. Against that cathedral's slow wheel, the Emberanring laboratory is small and precise. Ash learns to cohere, diamond keeps time, and second-generation worlds practice durability. Nothing here is miraculous, everything here is patient. Matter negotiates with gravity, with heat, with charge, until it discovers shapes that survive and then keeps them. And in those kept shapes, glass beads, welded breccias, faint magnetic scars, layered spectra, our instruments read a story that began in ruin and chose, methodically, to become structure. A ring like this also keeps its own census. Break a population of fragments often enough and the sizes relax toward a power law where small pieces dominate the surface area and big ones hoard the mass. Collisions then feed a steady cascade from boulders to flour while gas siphon from hypervelocities modulates the whole economy. The slope is not a commandment: clumping, vapor quenches, and magnetic weather tug it off script, but the trend gives the torus its look: optically thin in starlight, optically louder in the infrared, a veil whose brightness depends more on how many grains there are than how heavy the inventory runs. Vertical optical depth stays slim because gentle taps shear away inclination. The ring learns thinness like a habit, then enforces it with every orbit. Close to the compact star, mechanics writes with fine nibs. The hill spheres of nascent seeds are tiny, only within a skin of a few radii can a pebble be captured without tide stealing it back. That is why pressure bumps and vortices are kingmakers here. They slow pebbles just enough for sticking to outpace shattering and for drag to keep fresh fines flowing through the feeding zone. Gravitational focusing helps once a seed grows, but tides are always nearby, testing cohesion at every periapsis. A successful body ends up rounded not by ocean or air but by statistics, countless glancing blows that anneal porosity and erase corners the way a river polishes stones. Heat transport inside the dwarf remains eerily efficient. Electrons conduct energy so well that temperature gradients flatten quickly. The star cools almost like a single piece, not a layered onion. As the core crystal fraction climbs, the astroseismic spectrum shifts, mode periods drift with the changing buoyancy profile, little clock hands for a process that otherwise hides beneath a steady light curve. Trace isotopes whisper other stories. Neon settling releases a trickle of gravitational energy that pauses the fade, a soft plateau a patient observer can measure. Far in the theoretical distance, when almost all heat is gone, pycnonuclear murmurs might flicker in the densest layers, but those rumors belong to calendars no galaxy has yet kept. The gas ribbon that lines the inner gap is a truth-teller. Its double-peaked lines widen and narrow as the inner edge breathes. Slight asymmetries precess on schedules that reveal tilt. A transient brightening with no dust counterpart announces a collision so savage that rock went straight to vapor. Ionization rides the compact star's flares. When it rises, the ribbon couples to even modest magnetic fields and its turbulence hums a little louder. Zeeman splitting is the caliper for that grip, cyclotron harmonics the stethoscope for where curtains of matter land near the poles, and together they tie the chaotic now to the steady geometry beneath. Fragments that drift inward write light curves that look like weather reports. The first passes are deep and ragged, tails shed, periods drift, then the profile thins into wisps and finally vanishes as the train evaporates into gas or is digested by the star. Stack those events and a cartography appears, a convoy from a single disruption marching along diverging paths, a warp sliding its shadow across the dwarf, a shepherd body opening a scalloped gap and parading bright crescents that rotate with it. Because the whole workshop fits into a space smaller than some stars, the clock ticks fast enough for human patience, days to weeks for changes, months to map precession, a year to catch a cycle of busy and quiet seasons. Worldlets that graduate from rubble to stone collect signatures a distant spectrograph can still read.